Hello, my name is Morne McCartney and I'm doing Excel in simple terms, designing a game. Today we're looking at making a game of Tic Tac Toe with a computer player. So the majority of the logic I did in an Excel spreadsheet. So we're going to jump straight into it. I'm going to show you the AI logic. So in cell count, we basically want to know whether there is something in that cell or not. For this reason, you will see that I've got equals double quote in each of these cells because I basically want it to pass the value as a string. Now if I didn't do that, if I took it out, you see it's going to count, it's going to take that cell as a 0 and it's going to count it that something is in that cell when in fact there's nothing in that cell. So we're going to just put the quotes in there, and so when we link it to our final board, we will obviously tell it to pick up whatever's in that board on that board cell, and if there's nothing in it, then it must represent it with a double quote because you don't want the cell to be counted. Then in cell score, what it is doing there is it's having a look at whether it is nothing, which will obviously then be a 0, a cell score. If it is an X, we want it to give it a cell score of 1, and if it is a O, we want to give it a cell score of -1. The reason why we're doing this is because we want to be able to differentiate. When we look at the score, we want to be able to differentiate between the computer player and the human player. Now, the cells on its own is not going to help us to give the AI logic, because what the main criteria is to win is that you obviously have to have a row or column or diagonal filled with values, and it must all be the same value, being an X or O. So to be able to do that, we need to convert these cells into sectors. That's what I call it, being my entire row there, my entire row there, entire row there, the columns, each one of the columns, and also the diagonal positions, that one and this one. And those are the positions that we want to be able to add together and see if we get to a score of either 3 or -3, based on what we've already built here in the cells. So to do that, I created this little section here. Okay, so you can see the logic there is basically, so if you look at them, you've got sector 1. Sector 1 being this position diagonally. So you can see that cell 1 is basically your diagonal position. So it is this cell, and this cell. Now that is basically cell 1, cell 5, and cell 9, and that is what we've got represented in here. So we put in cell 1, 5, and 9, and you can see the red corresponds to the red section here, the yellow to the yellow section, and the green to the green section. So as we populate this field, it's going to first populate the cells, then it's going to check each sector, and the sectors, you can see the cell numbers are in there that builds up that sector. So in this case, we have cell 1 and we have something in that cell, so it's going to show an icon in cell 1, which is row 1, column 1. Now, initially I built this with these rows and columns because I basically started the program off by collecting the values from here to be able to access that formula. What I decided instead to do later on is build a section, build a function that will determine based on the cell number which cell, row and column is being referred to, which means at this point I no longer need this. So I'm going to delete this section here. I'm going to delete the row and columns here, because all of this workings are now actually going to happen inside my code. So I can get rid of that, and I can get rid of that, and that makes it look a little bit less complicated. So to give you an idea, so having a look at, for instance, cell 2. So cell 2 has nothing in it, and you can see that the sector count of that is nothing, the sector score of that is nothing, and it consists of cells 3, 5, and 7, which is the diagonal in the other way around. Now you can see that there is nothing in that position, so it has no icon in any of those fields, and as a result, its score. Okay, so let's have a look at sector count is 0 and its sector score is also 0. So I'm going to take. Now in this way, we can now add the sectors together and see whether any of these sectors are actually a 3. So to show you, we add 3 x's in all these cells. You can see that we don't get a count. This is now our sector 3. Let's say being player X plays the first diagonal across is 1. This one is 2. So what the program will do is basically then sort first by sector number. This is 7. The reason why we have 8 sectors that we are first sort by sector number is you will notice when you sort, we have 3 on X something that's already, and you can see the sector count for you are sector not 3 is 3 consistent, and the sector score is 3. It will mean there is a win. Let's say, for instance, you had 2 lines, one out of 4 and one out of 5. Is that we now have numbers, the same score and same values used, and they've been sorted a couple of times. So sometimes you're going to get sector 4 first, sometimes you're going to get sector 5 first. So the way it by sector number, we essentially resetting it. We're going to basically sorting this every time original order with every turn, and then we are going to be sorting. If we sort defensively positions, we would always get it into from the lowest to the highest, unless the sector score is obviously then higher by set number. So in this case, so that you can see the sector by sector is for defensive. From 1 to 8 out, irrespective of one position and the count. It's telling us that the computer should be playing sector 1, sector 3, or sector 6. Sort by sector count. The logic in that. So when you click that, you can see the sectors are mixed up across because it is sorting it by the count first, and then the score. 3. Or it should be playing sector 1, which is across diagonally. Which sector has the highest, or it should be playing sector 6, which is count of items in it. So the logic works well in just doing a simple sort. Then we have a defensive strategy, which is basically sorting it. I did the sort by what I did is I just went to developer, record a macro, and then when you click this button, I selected my field, and I fields to sort by. First the score, and much simpler to record the macro, and then you have aggressive, which is the other way around. So it's exactly the same. It is sort by sector score, and then by sector count. But it's going to sort it from when you do it like that. So this is basically the sorting functions. In this way, we basically get that first cell is the best position. So I've got to sort by sector number. These are just recorded macros. Playing sector, and I just renamed aggressive subroutine to the name that I actually would like to use in my program. And then I've got one for defensive and one for your best position, because there's nothing. You can see I'm using 2 fields. If you want to play aggressive, all of them. Except for the ideal position to play. The first one by sector number, only you can see sector. That it's saying that the best defensive sorting would be to play in this, but also sorting you cannot play there because every single one of the counts are already full. But the count first. So the next best strategy is defensive and aggressive sector 1 by the score first, and then sector by the 1 count being the position. And the only thing that differs is you'll see that. So descending now be the best situation. If it wasn't already a win, looking at this, we see on the so you can see it's descending in the one case, your best ascending in the other case. So I can be able to block this change positions. Now you can see that. So this defensively, this makes sense to cover those blocks. Now when you click aggressive, it's going to sort it the other way around. So now it's saying the best position to play is probably then sector 2, which is diagonally the opposite way across, this way. Or it's saying that sector 4 would be a good position to play, which being that would be your next row, and then sector 5, and then it's saying sector 7 and sector 8, and so it continues. So you can see it makes logical sense. Just with a simple sort sector, we basically got a strategy. Now that explains this section of it, except the last column here, that basically just looks at the wins. So this is a simple count if. It's counting each of the icons to see if they are an X and then putting 1 in for each of them. So they're adding the 3 counts together. So in this case, if we sort defensive, you can see that it's giving X wins a 1. So it's not a win because it's not 3 yet, but it's basically just counting it up to see whether we can get to a 3. And for the O wins, it's doing the same thing. It's adding them together. Now in this case, we're not swinging the sign to a negative because we want to compare like with like. And so now we have a strategy. So basically what the computer is going to do is you are going, as the human player, are going to play your play. It's going to sort it by sector and then sort it defensive. And it's going to look at the first score and see if the score is already 3, it means there's a winner. It's pointless for it to play that position. If it is a 2, it means that there's only one position that is available to it. So it's highly likely that it's going to want to play that position because it would be a blocking strategy. So basically it's going to run through these and find preferably use the first one. But if the first one's score doesn't make sense to try and block there, for instance, let's say X and O have played. So let's say we have played these positions. Now if it sorts it and it sorts it defensively, it's going to say, well, that score of sector score, although there's a 2 count, the score is 0. So it's not viable for it to play in that position in the third cell, because it's not going to make any difference. That's already blocked. So it's going to prefer rather to play in sector 1 or sector 6, where the score is not yet or the count is not yet 2, because the fact that there's a sector score, a sector count of 2 and a score of 0 tells it that it's already been blocked. So essentially what the computer is going to do is going to run the defensive, and it's going to pick up the first value and it's going to basically take note of that sector. Then it's going to sort it again, and it's going to sort it aggressively, and it's going to take note of the first sector value that's there. Again, if the first sector value doesn't make sense, it's going to step down to the next one, and it will continue stepping down to the next one until it finds one that makes sense. Now it has 2 values. It's got a defensive sector ID and an aggressive sector ID. So those values it's going to compare against each other, and whichever has the better score, the more preferable score for it to be able to generate a win, that sector value is going to be putting in here. So in this case we had sector 3 or sector 7 was basically our options. So it's going to look at that, see the score is -1 for aggressive, and it is 1 for defensive. It's going to convert the -1 to a 1, so it can compare apples with apples, and it's going to see, okay, well, both of them are actually the same. So in that case, it's going to prefer an aggressive score. So it's going to make use of sector 7, which is an aggressive score. Now you see them, just going to do this again, because the moment I enter a value here, you can see it immediately changes the cells that is possible, because these are the 3 cells that's in that sector. So if I'm just going to change it again so you can see the values of the cells here changing. If I say 6, you can see it becomes 1, 4 and 7. If I change it back to 7, it becomes 2, 5 and 8. So now it's decided on a sector. Now it has to decide on a cell. And what it's going to do is it's going to have a look at what is in those cells, and only cells that are not populated is going to be part of what it would consider playable. Now if there's 2 cells open, it's going to probably throw a dice and decide between one of those 2 cells that it will then play. And this will all happen in the code. It's just going to pick up the values from here. The sector value is going to populate here, give the cell values. It's going to pick up the cell values into your code from here, and then put a cell down that it decides that it's going to be playing. So let's say it did decide on cell 8. It's then got a row and a column reference here, which is a formula that's just looking up, and you can see I'm using the formula that lookup cell reference. This is a formula that I created inside my code, so I can refer to it and just on the fly. Now, initially, I didn't use these lookup cell reference formulas. I used a VLOOKUP, and I basically looked up to my to the sections here. So for cell reference, I basically used the cell number as the first part of the lookup value of the VLOOKUP, and I basically looked up in here, and that is what I use those individual columns for. But instead, what I did is I'm going to just show you how those get cell reference, get column reference, and get column row reference works. So essentially what I did is I created a reference, a cell formula, where I can pass it the cell number, and it is then going to, so 3 is the max grid size, and the grid is obviously a 3 by 3, so the max grid will always be 3. And that would then return the value of the row, and I have the same thing for column, and then I can convert it back to a cell number by just passing the row and the column and the max grid size. Now literally just say, I can go into the cell, I can say equals get row reference, pass it the cell number, give it the size of the grid, which is 3 by 3, and it's going to kick out a row number. I can do the same for the column. So you can see what I'm eliminating. I'm eliminating the ease error, the VLOOKUP, the lookup cell reference cell, which basically is an entire different pivot table or not pivot table, it's a table that I created here to just be able to look up from the cell and get the row and the column numbers. So I don't need that anymore. I can delete that. And this one I'm just going to change as well to get column reference. Get column reference, the cell number, and 3, and voila, I have my row and my column reference there. And let's just see if that worked. So cell 8 is basically, so this is 1, 2, 3, 4, 5, 6, 7, 8. So that sits in row 3, column 2. So we're going to get into that formulas and the formula of all these get cell ref, get col ref, and get row ref a bit later on when we get to our code. Okay, so for now, this is basically how it's going to work. Then just the last section on the side here is just a player log. And literally what it is just doing is after every player is played, it records, so you see a number here that's just a counter of this column S to get the position that it must place the next log in. So in this case it's going to take this value and add 1 to it, and the next entry will be done in line 5. And that's basically how the AI portion of this works. So that's everything for the logic on here, and you can see that it kind of gets it kind of works quite well. I think my logic is a little bit tough because I think the way I structured it makes it very difficult to win this game. And obviously, if you want people to play your game, you must make it possible for them to win. So the last section here is just this section here that shows draw or winner. Now the draw is really just going to check whether all 9 fields have been populated, and if it is populated it's going to give a true, and if it's not populated then it's going to give a false. So in a case where we have I'm just going to populate with just any values there. So the moment that all the fields let's see. Oh, it's using the board. So I've already moved this formula to use the main board. So let's link the main board to this so we can get values that's on the main board. So I'm just going to use a formula. I'm not going to equals it, because remember, if we just go and equals it to each one of these cells, we're going to land up with cells. Let me just show you. We're going to land up with zeros in positions that's not being filled. So I've prepared this little formula where we just say, if the board position A is nothing, then give us a double quote, and if it is something, then give us the whatever is on that board. So this is now linking it to our main board, so the game is ready to play. And you can see this is now a reflection of whatever happens on this board. So if we start the game and we click, you can see the computer player is anticipating the moves that we've made, and it gives us the game is a draw. The moment we click the start button, it will change this section, it will clear out the board, it will change this to show us the player that is in play, so player turn is X. At the same time, it's putting, now normally I would not put this on my user interface, I would put it in a separate sheet called init, but just to make it simpler to show in a video, I put these values on this sheet. So ideally you would not want it here, you don't want the user interface to be contaminated with all kinds of other things, but you could also just white it out. But basically what this is this is the player number. So the moment it's, the AI player plays, it will change that to a 2, and this will become an O. And this cell here, I'm going to just enlarge it so I can show you a bit better. Any cell that I click on, this is the column and the row reference that is just appearing there. And we're going to quickly step through the code, and I'm going to show you how I bring all of this together to get to a working game. Okay, so in sheet AI, I have no code whatsoever. There's nothing necessary there, because that is just our logic, and our code is going to go and pick up from the AI sheet whatever it needs. In the board sheet, we have basically, I obviously do my option explicit, and I dim my variables, both of them being integers. And the only actions that I take there is when the worksheet activates, I wanted to check whether the toolbar, and the toolbar is this little box at the top that says start game. So it is just a form with a single button on it, and I just want to check whether it's visible. If it's not, then it must show the toolbar. Then the next section is where I record whatever cell is being clicked, and I write it onto the sheet here in column in G1 and H1. Then I said, if the active row is greater than 3 or the active column is greater than 3, then exit sub, because I don't want it to proceed. If you're not clicking on the board, I don't want it to proceed with placing X's and Y's in the position where you clicked. That action must only happen if you're clicking on the 3x3 board, and so the moment you click somewhere on the 3x3 board, it's going to call the subroutine start game. Then in my workbook, the moment you open the workbook, I wanted to switch to the graphic user interface, in other words the board sheet, and I want it to also check that whether the toolbar is visible, because we want the toolbar to always sit at the top of the screen when you're playing the game, so you can restart the game at any point. Then in the toolbar, if we go and have a look at the code in there, so when you click that button, it's going to reset the board, and we're going to walk through the code for the reset board. And then just for the toolbar itself, I want it to sit in the middle of the screen, right at the top, over the Excel menus. So to do that, I basically just set 20 from that's 20 pixels from the top. And for the left position, I took the application width. In other words, that's the width of your application that's running in other words Excel, and then I minus half of the width of the actual toolbar, so that we can get it positioned right in the middle of the screen. And I just deduct that half width off the full width of the application, and that gives you the center position of where your toolbar is going to be sitting. Then we have the three functions that where we call the cell reference. So the one is get cell reference. That's when we have the row number and we have the column number, and we want to return the cell number. And then the other way around, we've got where we have the column number and the row number. So that's these two functions, they will work together. And so we will pass it the cell reference and just the size of the grid. Now, I could have hard-coded a 3 into the cell grid, into grid max here, but I always develop my code so it is reusable. So I can literally come and copy and paste it and use it in my next program that I do. So the grid max is basically also then an integer. In this case, it's always going to be 3 because our board is 3. Now this will only work for a square board, because if you have a board that is oblong, you will need 2 grid maxes. You will need one for the columns or for the horizontal positions, and one for the vertical positions. And the way these functions work is quite straightforward. I'm going to demonstrate it a little bit on my Excel spreadsheet. So let's say we are picking so we're going to look at get cell reference first. So we pass it a row number, and let's say the row number is 1 and the column number is 1. Now we wanted to return the cell number being 1, because that is the cell that is in position 1, 1 would be cell number 1. So the way we do that is by taking the row reference minus 1, because you're going to be in the first row. So you have 2 integers, so which you are going to be need to use to be able to, and that's the column and the row reference that you're going to need to use to get to that cell number 1. So what we do is we take the row number and we deduct 1 off it, so that gives you 0. We times it by the grid max, which is 3, and that still gives you 0. And then we add the column reference to it. And that works for any size grid, as long as you give it the right grid max value. In other words, 3, because your grid is 3 by 3. And you can test this. And I normally, when I work out a formula like this, I would test it. I would just take random cells on my sheet and just make sure that it holds true for each one of those cells. So let's take cell 9 and we check whether that holds true for it. So 9 would be that's the value that we want returned, and we're going to pass it a value of 3, and we're going to as the row reference, and as the column reference we're going to pass it 3. So row reference minus 1 gives you 2, and 2 times 3 will give you 6, plus your 3 for your column reference will give you 9. So it holds true for the first position and it holds true for the last position. And you could also test it on the middle position. I normally test a formula on a couple of positions just to make sure that it always holds true. But you can see this formula is steady and it does hold true on all of those positions. Now for the column reference, we had to use a slightly different method, because you basically have 2 formulas. If you take cell 1 and you divide cell 1 by so cell number is 1 and your grid max is 3, and you can see that the 2 formulas I've got here is the one is get column reference equals grid max, and that is if your modulus when you divide the 2, the remainder is 0. But if it is not 0, then it is equals to the modulus, because that means it is definitely in the last column of your grid. So you can see there's 2 formulas. We're testing with there's a modulus left, a remainder left, and if there is a remainder left, then we can literally just set it equals to the modulus. But if there is nothing left when you after your division, then it is equals to the last column. In other words, it's equal to the grid max. On the row reference, we're also testing for modulus, but for a different reason. Because in that case, we are going to take the cell reference and dividing it by the grid max. And that is only if the modulus is 0. In other words, it's in the last column. If it is not in the last column, we're still going to do the division, cell reference divided by grid max, but we're going to add 1 to it. So let's test if the get row reference holds true. So we're going to have a look at the cell reference as being 1. So 1 divided by your grid max is 3. So 1 divided by 3 will give you 0. And because there is a modulus, it will use the second formula, which would add a 1. So 0 plus 1 would give you row 1. So that holds true. Let's see if it works on cell 9. So cell 9 divided by 3, the modulus is 0, and the result is 3. So in that case, we're not going to add a 1 because the modulus is 0. So it's just going to be cell reference 9 divided by 3 will give you 3. That is in row 3. So this function always holds true. It's always a good idea when you try and figure out a function like this that you try and check whether it will hold true on all the possibilities before you run your function and it maybe falls flat on certain things. So this has been tested. It works on bigger grids than this. So this is also a formula that you could literally just copy and paste out of here into any other program that you want to use, where you want to pass a reference and get either the column or row reference or the cell reference out of it. Then the next section is where I use my dice. Now I normally have 2 standard dices that I use. This is the base formula of both. The other dice function, so essentially it's just a value between a minimum dice and a maximum dice, so between 1 and 3 for instance, and it's going to kick out a value somewhere in between those 2 values. Now if you want to do a dice with a negative result, then what you would do is I'm going to show you on the spreadsheet here. So let's say you want a value between minus 100, sorry, this cells are colored white, so I'm just going to color them so we can see what I'm typing. Okay, so let's say you want a value between minus 100 and 100. So what you would need to do is you would need to take the minus of the minus 100 and add your 100 to it, and that will give you 200. Now I'm just going to paste this formatting. Okay, so now in the case, let's say it throws the dice and it gets minus it gets a 50, because remember the dice function cannot throw a negative number, so the only way you can get a negative number is by converting it to something else. So let's say you get 50, so then again you would, from that you would remove the 100 that you initially had. So a 50, a 0 would mean a 0 in that case would mean a minus 100. And so it would step up until it gets to 0, and a 0 would be a minus 100. When you start getting to amounts higher than 100, you will start getting into the positive range. And obviously when it gets to 200, your dice result would be 100. And that's how you would do it when you want to generate a negative dice as a possibility. So for this case, I didn't need that because I'm not going to throw negative dice. I have these squares, and The only time I'm going to really use the dice is if I want to pick between two options, or maybe one cell has been played and the two other cells are equal, are equal chance or equal risk of playing. Then the computer is going to throw a dice to decide which one of those two cells is going to be playing. Okay, so now the next section we're going to look at is the get sector ID, score, and count. It's three functions that's in there. Literally what this is going to do is I'm going to pass it a value, an element number. So if I pass element 1, it's going to be picking up from your AI sheet, it's going to be picking up the first line here. So when you look at the code, it's basically taking 13 on the row number on this worksheet, on the AI worksheet, and adding the element number to it. So what this will allow me to do is just pass the next number, the next number, the next number, and let it step down until it finds a suitable strategy for it to follow. The get so that's basically then going to return the sector. This one is going to get sector count is going to return the count, and get sector score is going to return the score of that value. And in that way, I can then get those values and collect it for my defensive strategy first, and then my defensive strategy, and then compare those two values to each other to see which strategy would make more sense. Then on my get winner, basically I'm going to firstly go to change the check who the winner is on the AI sheet, so that I'm going to pick up from cell G10, and I'm going to if the winner shows a true, then or if it has a value in it, it is true, and in that case I'm just going to report it on the board. I'm going to put those two values, check winner and the person won. So in other words, it's going to say X or O wins. It's then going to just clear out on the board this little X here, because it's already going to say X wins, so you don't want an X sitting in that field as well. And then it is going to come and obviously it's marking the get winner as then true if that is the case, and then it is going to get the winning cells. So that is the 3 cells that we've highlighted here, and it's going to then mark them. So we basically want the row and the column reference for those guys, for the 3 cells, and then we're going to paint those using the paint function that we built in here. So the paint function has 2 options. It gets a row and a column as its reference, and the status as a string. So the status can either be R, which is reset, and that basically makes the entire board green again. And if it is a W, then it is going to only paint those 3 tiles that gets passed to it in yellow. And that basically is what is happening here. Then my place icon. Now initially when I did the place icon, this is for the computer player, because remember when you click, it automatically knows the cell and it's going to place it in that position. When the computer clicks, when it's its turn, it's going to get a tile number passed to this as well as the icon, which is O. It's going to collect the row reference and the column reference, and then it is going to place the icon. Now initially I didn't use this, and you can see this 3-line formula will hold for any size grid. Initially what I did is I used case numbers, and I gave it explicit positions where it must place each for depending on the tile number that it gets passed. Now what is the downside? You can see already just with 9 I had to have 9 cases for this. So when your grid becomes very big, let's say you're doing your own game and you have a 100 by 100 grid, you're literally going to have 10,000 cases. So it will become hugely impractical to do it in this using this method. Instead, I can get totally rid of the cases, and with 3 lines I can do any size grid. And that is what makes it more logical to use this method to place the computer player's icon. Then the sort we had a look at earlier a little bit. and that, as I said, was just pretty much recorded. I basically just came and highlighted the fields. I didn't highlight these formulas because they are always going to be the same formulas in the same positions. I literally just highlighted this section and I sorted by recording a macro. And then I just went and renamed that macro to give it names that I want to use in my program. So that is that for all of the helper components, if you want to call it that. Then we obviously have our main component, and that is where the core of the game runs from. But before we get that, I'm going to show you the AI strategy and how we are collecting the values from our AI sheet to make decisions. So the first one is the sector strategy. And as you can imagine, we first go and sort defensive. But before we sort defensive, we just want to sort, as I mentioned to you, we want to sort by sector number first, so that we are not sorting on a previous sort. We kind of have a little bit of a reset every time that we are sorting. So we're going to I'm going to put sort by sector number in there before this one, and also in here. So we basically then sort by sector number, so they're going to be from 1 to 8, and then we're going to sort defensive, and from that we're going to pick up the value of the sectors, and so in this case we are picking up the first value, and what we then do is we have the sector ID, we've got the count defensive, and we have the score defensive. So these are all my defensive values. Then I resort aggressive, and I go and I pick up all the aggressive values. Once I've got those two values, then I do a comparison between the two of them. So I'm going to say if the score defensive is equals to, and remember the one is a negative value, the other one's a positive. So if we want to compare them, we need to swing one of the signs, and that is why I have a negative aggressive. So I'm going to convert my negatives to positives. And then I can compare a 2 for the one player to a 2 for the other player. So if the defensive and the aggressive score is exactly the same, in other words they're both 2 because I've converted the -2 to, and it's also a 2, then it's going to throw a dice to decide which one of those two scores it's going to follow. If the defensive strategy has a higher score than the aggressive strategy, then it's going to pick the defensive strategy. And if the aggressive strategy is better, then it's going to pick and it basically picks it by selecting, by recording the ID. So that's the sector ID that it's going to pick up, and we are later on going to then use that sector ID by placing it onto our spreadsheet. If you recall, we have the cell where the sector ID is going to be populated into. Then if the sector count is 2, it means that someone is about to win. Now it's not someone, it is the human player. So I'm going to just change that to say means human is about to win. So then we want to follow the defensive strategy, because the computer wants to try and block the human from playing. So then the defensive strategy would take priority. Now if the score is -2, it means that the computer is about to win. And in that case, it wants to follow the aggressive strategy because it wants to place it somewhere where it already has the highest score. And then the next step is just placing that strategy down onto the sheet, and voila, it is done. So this portion I initially built because with the 3 buttons I wanted to build a third strategy based on the sector count, but then I decided to rather build it into the defensive and the aggressive strategy. So technically this sort is no longer necessary and it can actually be deleted, but I left it there just for educational purposes, and so you can see how that function will work. So this piece of code is really no longer needed, and I'm just going to remove that. Now once it's decided the column or the sector that it is going to follow, then we can switch to the cell strategy. And on the cell strategy, we want to basically go and record whatever. Once it's put the sector in, it will have 3 cells. So we're going to go pick up that cell, and we're going to go to pick up the 3 cell values. And you can see if the sector was 5 that it decided on, then the only position that we have available to play would be 7. So in here we're also stepping through it, and we're seeing is all 3 cells occupied. If none of them are occupied, in this case none of them are occupied, so then if there is no preference, then it's going to just throw a dice and in that way determine which one of the cells to play. If the last cell in the sector has been played but the other 2 cells are empty, then it's going to throw dice between 1 and 2 and decide based on that 1 or 2 that comes out which one of the strategies to follow. And the same happens with all the others. The middle cell is occupied, has been played, and all the other cells have not been played. Then the first cell has been played. Then we have one for 2 cells that's been played, and only 1 is remaining. And that's 2 cells on the one edge, 2 cells on the other edge, and 2 cells on the third edge. And then if all cells have been played, then it means when we selected our sector strategy, something didn't go right. It means that we picked a sector where everything is already played and we cannot play that sector. And in that case, we wanted to basically step through every cell and find a random cell or the first available cell where it can play, and then play that position instead. In the meantime, remember, as it steps through, it will be checking the whole time whether there's a winner. So if it's picked a strategy where all the cells are played and that was the most favorable strategy, there's a big chance that somebody has already won, and so then it would never get to this code, because in our main section we would catch that. Now our main board basically consists of 3 components. I think it was 3. Yes, it's the reset board, the start game, and the toggle player. The toggle player literally just swaps the 2 players around. So if it is player 1, it changes it to player 2, and it changes the player icon to O, and it writes that to those cells on the board. If you recall, on the board we've got the X here, so that's where the icon will go, and this is where the player will go. And then vice versa. If the player is 2, then we'll switch it to 1 and change the icon to player 1's icon as well. Then the reset board is when you click the button, that is this piece of code that will be run. So what it will be doing is it's going to first select your AI sheet, and it's going to go clear out your player log. So that's the section here on the side. It's going to select this section and clear it out. Then the next section that it does is it clears your board which is this green board. And you can see it does that by stepping through each of the rows and each of the columns and just clearing it out with a double quote. And then the next step is it's going to go paint the tiles using our paint tile function, and it's got R as its variable to denote a reset. Which means it's going to be painting everything green, because if you've already played a game, something will be highlighted in yellow if there was a winner, and we obviously want to start the next game with a totally green board. And then in this position I set it to always start with player 1. Now you can put a dice in here, a dice between 1 and 2, and get it to flip the player depending on which player you want to start, whether you want the AI to start or whether you want the player to start. However, my start game code I wrote in the order that the human player's click is what initiates the game to start. So the human player in this game will always start first. And the way it will do that is it will obviously go and set the player number, or collect the player number from the board, and that is the board position. Again, that board position F1, which is where we stored the active player or the current player. then it is going to go and check whether there's a winner and whether there's a draw, and that is it's getting from your AI sheet. And in either case, if either one of those are true, then it will reset the game, or sorry, it will end the subroutine, exit that subroutine. If there is no winner, then it will start with the human player by collecting the player's details, the player number, the player row and column, all from the board, setting the player icon to X, and then collecting the cell content of the cell that was clicked. Now, the cell that was clicked must be empty, because if there's already something in it, you can't play that cell. So if player cell content is empty, then it can place its icon. If it is not, then you would have to pick another cell. Then it toggles the player, also using a function that we wrote, the one where it swaps the two players around. And then it checks for a winner again, because then the human player has basically finished its play. Now, with the AI, there's not a lot of code that sits here, because most of the coding is done in the cell strategy and the sector strategy. So all it basically goes and does is it logs the position of the human player that played last, and then switches over to get the record the details of the log, and then the AI player starts. So here it's just going to collect the AI's sector strategy and the AI cell strategy. It's going to log them. It's going to place the AI tile on the board using the place icon function, and then it will check again if there's a winner and toggle the player. And literally that is the game. That is all the logic that is needed to get the game going. Now, I mentioned in the previous section when we were talking about the AI, I mentioned that we would be stepping down if the strategy, the initial strategy, is not a good strategy for the AI to use, and that we did not build into this game. So I'm going to show you in the next section how to add that strategy, where, for instance, if the sector count is a 3, then you shouldn't pick that cell, because the cell is already played to its full extent. Because if you pick that, obviously if you sort it defensively, you are going to get the one with the highest sector count being a 3, and you can't play any cell because all the cells have already been played. So we need to build a little bit of code in just to rather step to the next strategy then and find a sector where all 3 cells have not been played. Also, if your sector score is 0, but the sector count is also 2, it means that the 2 different players have played. So that should not be one of your most important strategies to follow if that cell has already been blocked. Then you should rather the AI should rather step to the next cell and find a strategy where there's a better chance of actually getting a win or a block. Because it makes no sense to block something, a sector that's already been blocked by having X and O played in that sector. So the next section we're going to just cover that and see how we can get that to advance to the next possible strategy to find the ideal strategy. So first, to be able to get it to step down, we need to create 2 counters. So this is my dim for my counters. So you can see there's 2 dims, one for a counter for aggressive and one counter for defensive. Then we're going to go and modify this. We're going to give counter defensive a value of 1. And what we wanted to do is then use this counter defensive instead of this value 1 here. And then we're going to do a do while loop. And as long as the sector count defensive is 3, we don't want to select that. So we wanted to, if the sector count defensive is 3, it must step to the next possible counter defensive. So we're going to say counter defensive equals counter defensive plus 1, and then we're going to collect these values again. Just want to format it properly. So now it has picked up the counter defensive. It sees that it has a value of 3, so it needs to find an alternative. So it's the counter defensive, it's adding 1 to it, and then calling the next counter defensive strategy, and then so it's going to continue doing this, but we have a second condition. So the one is if the counter defensive is 3. The other one is if the counter defensive, so we're going to do another do while. Do while counter defensive equals 2 and sector score defensive equals 0, because it means then that the 2 players have played. There was one with a 2 that played, one that is a plus 1 and one with a negative 1 has played, so their score is 0, but the count is of those is 2, and we're going to do the exact same thing. We're going to increment the counter and we're going to loop. Now we need to do the same thing for aggressive. So in the aggressive section we're going to do exactly the same. We can literally take the sort aggressive is valid, then we're going to do a counter aggressive equals 1. We're going to change the ones in here to counter aggressive. And then we're going to do our do while loops. Do while sector counter aggressive equals 3 and a loop. I'm just going to copy this and I'm just going to change the defensive wording in there to be aggressive. So we're going to just select that and we're going to do a replace wherever it says defensive. We wanted to put aggressive. Okay, so that's this do loop, and then we also want to do the loop if the score is 0, because then that is also not our priority. And also these defensives we're going to replace with aggressive. And there we go. We now have 2 loops that is going to check whether it is either aggressive or the aggressive score is 3, or whether the count is 2 and the score is 0. So let's check whether this works. So we're going to go just click off AI and back there so we can start a game. Okay, so it's complaining about variable not defined. Sector counter aggressive. It's sector count. Let's jump back. I just want to alter my code so I can start the code again. Start the game. And you can see that it is playing quite aggressively. It does, the way this game is structured, it does make it quite difficult for the human player to play. So I do recommend that you look at ways of putting more random positions in that the computer will be playing. I think you could probably, I think you may have a chance of winning if you probably play corners. It looks like it is quite aggressive in where it positions itself. I just want to see if it is possible. There we have a possible win. So we have found a way of winning the game, not easily, because you can see that the computer strategy is quite aggressive, and you can see if we click again, there's a win condition, so it's not going to allow you to click until you restart the game. And you can see on the AI board, it's recorded all the moves that it took to get to win. But here you basically have a game of Tic Tac Toe that is working, where your AI can determine whether it should play a position or not. So experiment with it, play around with it, and see how you can make it a little bit more easier for a human to win if that's what you choose. If you want your game to be almost unbeatable, I think this is the strategy. It's maths against brains. So I think in the way we've set it up, the maths is going to win most of the time. I think there is a chance, like you saw, that it is possible for a human to win. Yeah, so, but essentially it's quite an aggressive strategy that the computer player picks. To make it a little bit more reasonable, you may look at changing the order of your sector strategy, because the cell strategy is quite random. It's mostly dice plays. If you look at the code, it's mostly dice throws to decide where it is going to place it. The computer strategy, on the other hand, is only really when it's equal that a dice is being thrown to decide the sector. The rest of the time, it targets whatever is the highest score for between aggressive and defensive. So I think it is a game that you can possibly win as a human player, but with difficulty. So thank you very much for watching the video, and to learning how to use AI in your Excel games. And please follow and subscribe if you like the video. The code is downloadable from my website, bringmesome.co.za. So I invite you to download code. My code is free to use. You can modify it in any way you wish. You can use it in your game, even if you decide to do a commercial game that you want to sell. You are most welcome to use my code. I feel that it helps more programmers enter the market. Once you know Visual Basic, it's not a massive step towards learning something like Python. And Visual Basic is handy for it's not just a game. Excel is a great games engine, because it does have a lot of capabilities that you can leverage, like you saw now, without doing too much hard work. You can do a lot of your calculations in your spreadsheet itself, but it is it's an entry to other programming languages if you choose, but also all the code that you see here is not just game driven. It can be used in any application. Something like a grid you can use for statistics to calculate probabilities. So once you've got this kind of knowledge, and you know how to use things in games, is just a nice way to teach people how to use the code, but it has many applications. It's something like your dice throw helps you to create random events. If you want to test, for instance, a business strategy against random events, you can use the dice throw. You can things like your grid lookups and that kind of thing can be used in many other anything from writing a POS system to something where you want to record data on a specific table and then be able to quickly reference it just by calling the cell and the row, and maybe giving your database numbers, and you want to be able to just call the number reference and it automatically goes and picks up a specific cell and row. So there's many applications for what you've learned here, so please feel free to use the code. It is, as I say, it is downloadable from bringmesome.co.za, and I welcome you to download the code and play with it and modify it any way you wish. Thank you very much and have a good day.